Welcome to the Rakuten SixthSense Cognitive AI Engine home screen. This dashboard is designed to provide a comprehensive overview of system performance, identifying anomalies, and tracking efficiency metrics crucial for operational health. This majorly includes the Overview section and an elaborate Anomaly Impact section. The Overview section provides a quick summary of the operational scope, including the total number of sources, applications, metrics, and anomalies recorded. Changes in these figures can indicate new integrations, increased monitoring scope, or shifts in data capture strategy. The Anomalies panel displays the number of anomalies detected over 2 consecutive periods, offering a comparative insight into the system's stability. A change in this count is an immediate indicator of the operational trend. The top anomaly-causing metrics by impacts ranks metrics based on their frequency of association with anomalies. These pinpoint the aspects of the system most often linked to instability. Focusing on the impact of these metrics helps prioritize efforts in system tuning and preventive maintenance to enhance overall performance. On the other hand, the top impacted metrics chart reveals which system metrics are most affected by the anomalies. This assists in identifying the broader impact of performance issues, guiding teams on the areas to focus their remediation efforts. In the Worst Performing Metrics section, the top metrics that have frequently underperformed against established performance thresholds are listed. Each metric is evaluated based on the frequency and severity of its anomalies, as well as its impact on overall system stability and efficiency. The Worst Performing Sources and Worst Performing Applications sections identify data sources and applications that are consistently associated with poor performance or high error rates. This targeted information helps in allocating resources effectively and improving the quality of service delivery. To filter the data presented, one can select the time period for the data you wish to view, either in a relative or absolute format. Relative time allows for quick selection of predefined intervals, such as the past few minutes or days, while absolute time enables the selection of a specific date and time range. You can further refine the data displayed by choosing specific sources or applications from the drop-down menus. This allows isolation and examination of metrics from a particular system component or application, making it easier to pinpoint issues directly related to the selected areas of your infrastructure. Let's click on Total Sources to explore how sources are added and managed, providing the foundation for our monitoring capabilities. In the SixthSense Cognitive Engine, sources are crucial for gathering data. These sources could be anything from Prometheus servers, Cortex storage systems, or direct SixthSense agents. Each source box provides key details such as the type of source, the number of applications monitored, the metrics being tracked, and the anomalies detected. Creating a new source involves selecting the source type, either Prometheus or Cortex, and filling in the necessary HTTP details such as the endpoint URL and headers. Set the query interval to determine the data retrieval frequency and the timeout to manage response expectations effectively. After creating the source, you can define applications and metrics to ensure comprehensive data capture. This step is essential for establishing a robust monitoring framework that aligns with your operational goals and provides extensive observability across your infrastructure. Let's explore how to edit the configuration for the GCP demo OTel source. In the editing panel, you can adjust the HTTP request settings, which include the URL and headers. Here, you also set the query interval, determining how frequently the engine pulls data, and the query timeout, which defines how long to wait for a response before timing out. To tailor data collection, you can associate specific applications with this source. This involves naming the application and setting up metric queries to specify what data is collected, how it's aggregated, and the refresh rate. As we select a source and navigate to the Behavior tab, we are introduced to a detailed visual display of application performance, integrating both real-time data monitoring and predictive analytics. The dashboard presents various application metrics through dynamic line graphs. The orange line, representing the actual scenario, or ground truth, shows real-time application performance. The blue line, marked as the forecast value, predicts expected behavior based on historical data, setting a benchmark for normal operations. The confidence interval is shown as a lighter blue shade around the forecast line, indicating the expected range of metric values under normal conditions. This is crucial for early anomaly detection, providing immediate feedback on the stability of the application. Watch as the orange line fluctuates, ideally staying within the confidence interval. Breaches of these thresholds will be marked on the graph. This graph captures instances where multiple anomalies have occurred. When actual metric data surpasses the upper threshold, it's marked as a major breach, indicated by orange dots. These breaches signal significant deviations from expected patterns and are crucial for identifying stress points or potential system overloads. Minor breaches, represented by yellow dots, indicate less severe deviations, pointing towards emerging trends or potential issues before they escalate. Critical breaches, highlighted with red dots, denote exceptionally severe anomalies that necessitates immediate attention. Let's now delve into the Anomalies tab, where we focus on the detailed monitoring of detected issues, categorizing them by their severity and nature, enabling a more systematic approach to incident analysis and response. The anomaly timeline for a source shows the 10 most recent anomalies. This acts as a chronological guide, helping in tracking the frequency and timing of incidents effectively. Directly below the timeline, the observed correlated events provide insights into related metrics like CPU usage and memory, which were recorded close to the anomaly events. Understanding these correlations is crucial for hypothesizing potential causes and devising appropriate responses. By selecting the drop-down arrow beside each anomaly, we gain access to a more detailed graphical representation of the event, illustrating how the actual metrics compare against our forecasted thresholds. Within the expanded view, we distinguish between breaches and divergence. Breaches are marked by color-coded dots, orange for major and yellow for minor, each signaling the severity of the threshold breach. This visualization helps us quickly identify points of concern requiring immediate attention. The divergence section offers a dedicated analysis of anomalies that deviate from expected patterns without necessarily breaching thresholds. It highlights subtle irregularities that might not qualify as breaches, but are essential for predictive maintenance and system optimization. Each anomaly has an option to be acknowledged, allowing users to track their resolution progress and confirming that an anomaly has been reviewed. In the multivariate analysis section, we delve into the complex interactions between different metrics to understand their influence on one another and their collective impact on anomalies. This detailed analysis is crucial for diagnosing and resolving systemic issues effectively. Each color in the causal analysis diagram represents a different aspect of anomaly interaction. Blue represents the current anomaly, which is the primary issue being analyzed. Orange signifies causing metrics, which are believed to be the primary contributors to the current anomaly. Yellow highlights intermediate metrics that may indirectly influence the situation, and red denotes impacted metrics that suffer as a consequence of the anomaly. This color coding helps quickly discern the contribution of each metric to the anomaly. The contribution filter reflects the AI model's confidence in its predictions. As the model undergoes further training and refinement, its predictive accuracy will increase. When the filter is set to a lower value, it displays a broad spectrum of metric correlations, capturing all potential influences, even the minor ones. As the filter is adjusted higher, it focuses on the most impactful metrics, those the model is most confident in, reducing the visibility of less significant connections. Let's delve into analyzing the current anomaly, page drops. As we focus on the current anomaly, we can enhance our understanding by pulling up its associated data in the causal analysis diagram. This allows us to observe its direct correlations and trace the influencing factors. Upon selecting page drops as our point of focus, we immediately observe its correlation to K8's cluster CPU usage, tagged as an intermediate anomaly and highlighted in blue. To delve deeper, let's pull up this intermediate anomaly to explore its underlying causes. We trace the influence back to an increase in app load, identified as a causing anomaly, and highlighted in orange, which heavily taxes the CPU. This sequence highlights how heightened app load leads to increased CPU usage, ultimately impacting page performance with notable drops. This visualization not only clarifies the connections between these critical metrics, but also aids in pinpointing the root causes of the issues more effectively. Understanding these connections enables operational teams to target specific areas for optimization and preventive measures. In addition to the causal connections, this section presents several graphs under correlated anomalies. These graphs display real-time and historical data for metrics such as page drops, CPU usage, and application load. Observing these graphs allows teams to pinpoint temporal patterns and fluctuations in performance that may correlate with detected anomalies, providing further insights into their potential causes and impacts. Now, after examining how anomalies are detected and analyzed, let's explore how we get notified about these anomalies. By clicking on the bell icon at the top of the nav bar, one can access the Alerts dashboard, which is central to managing and monitoring alerts that notify you of potential system issues. This dashboard provides a comprehensive display of all active alerts, along with detailed information such as the severity of each alert, associated notifications, silence periods, and timestamps for when each alert was initiated and last updated. This setup ensures that you can quickly understand the current status and urgency of each alert. Setting up a new alert is straightforward using the Set Alert option. This feature allows you to define specific conditions for an alert based on the source, application, metric, and the number of anomalies detected within a designated period. You can also establish a silence period to prevent alert fatigue and incorporate custom messages for recipients. Alerts are classified by severity to help prioritize responses efficiently. Major alerts signal significant issues needing attention, but are unlikely to immediately affect system operations. Critical alerts indicate severe problems that could substantially impact system availability or performance. Alerts classified as both major and critical denote extremely urgent issues that could result in catastrophic system failures, necessitating immediate action. Editing an alert involves adjusting its conditions or deactivating it as required to ensure your monitoring system remains closely aligned with your operational needs. Deleting an alert is just as simple, facilitating the maintenance of an up-to-date and relevant alert management system. With Cognitive AIOps, elevate your operational intelligence to new heights, harnessing the power of advanced AI-driven analytics to keep your systems resilient and responsive.